I think it's really interesting how NASA, as historically they fulfilled this mission to join this space race and really do some due diligence and research in how to best support a team of people going up to the moon and all of the communications, all of the designing, all of the different mission critical tools they created so that they could safely send this team up to the moon and furthermore use that same technology and repurpose it for other implications in society. And I want to touch base on a few different examples here. So, as I'm sure it's obvious, NASA has spent a lot of time on satellite development, and a lot of the people that they do hire and professionals they hire are engineers who are extremely specialized in physics and understanding how a satellite travels through orbits and how electronically all the circuitry and how all of this technical components combined together provide different use cases for different sorts of people. Now, back then, it was for astronauts so that they could communicate with their team and see how they're doing, relay mission critical information. But now there's different applications for it, and it's trickled down to society in different manifestations, such as our GPS. Now on our iPhone, we can go type in an address and it'll direct us route by route. And road by road, we'll have a very in-depth definition of how to get to the certain point. Before, 2000s, we would have to focus on getting a map, using a highlighter to map out which highways you're going to take for a road trip from Boston to Delaware, or wherever else the case. So this sort of satellite development technology and how NASA repurposed this research and allowed innovation within society is very interesting. Now, there's also entertainment. Now because of satellite development, we can entertain the idea of being able to watch cable television through satellites. And that sort of communication tools and entertainment tools are a further development of this design thinking that I want to touch base on. A really cool example that I also found was something called a cochlear implant, and this gives the ability for someone who's severely deaf to be able to hear again. And I have a video of someone actually being able to hear again after they lost their ability to hear very severely in an accident. And here's a quote from Sarah Sherman, who we're about to see, who's going to be able to hear after many years when she lost her hearing. So you can see, the impact that the cochlear implant has on her life. So I want to talk about Adam Kasaya, who actually developed the technology to enable cochlear implants to actually work. Now, he alone did not develop this device, but he was one of the major reasons why they could make strides in this direction and sort of delegate this research further to other specialized individuals. And Adam Kasaya really had a great handle of telemetry and how communication waves work and how that may interact with satellites, different technologies, circuitry. And this man, with no medical knowledge, no biotech knowledge, was able to really make a huge dent in that research. Now, that's really innovative because that's created such a big difference in Sarah Sherman's life, and I'm sure many others. Some very interesting medical advancements that NASA is able to contribute to are a lot of different imaging diagnostics. So MRI and CAT scans, the wave technology of how frequencies work to be able to screen and look for different sorts of diseases wasn't possible until the research came out of NASA's Jet Propulsion Laboratory. So the different types of scans here are used in so many different diagnostic needs that we have as with doctors today, from a fracture to a much more bone density look. You can see all of the different types of impacts that NASA is able to develop through the research that they didn't just let go. So I want to make a comparison with sort of like an engineer, an engineer who codes. A lot of times they spend a lot of time using logic and thinking about how to solve complex problems. But a lot of times that same framework or mentality or logic can be replicated in many different use cases. And I think that's what NASA did a great job of being able to really replicate their already done research and being able to delegate it to further specialized individuals to make something else out of it. And here's a perfect example of how they did it in medicine, being able to filter space fluid and using that same technology to apply it in filtering blood. And now we call that a dialysis machine. So here's a typical example of what a dialysis machine may look like. Another cool innovation is this device called a bioscan. Now this uses infrared beams to detect any masses and tumors, another forefront of innovation within medicine. Now, as I'm sure you know, NASA did land a spacecraft on the moon, and during that time they used something called temper foam, and that had to be wrapped all the way around the entire spacecraft so that the landing would actually be soft. Now, this same foam is used in my mattress, my pillow, military vehicles, sports safety equipment, and all kinds of different applications that the same material was used in. And the same thing from the moon boot. The moon boot came out with much more focused on stability and control because gravity is taking a big place there. And using that same sort of focused design thinking principles, they were able to replicate that in ASICs. ASIC shoes are pretty known to be good for running, and I'm sure they replicated a lot of the stability and comfort that they had in the moon boot, or control more so that it impacts the runner progressively. So I think my main conclusion here is design think has made an impact all around us, and I think it's important to analyze how it has already been done so in our surroundings so that we can become inspired to do so in our future surroundings.